Hey, welcome back. This is Rashid. Thanks for joining. Appreciate your time. So we have already covered several topics on this what I call it RTL2 routing topic. I'm taking a block, a very simple block, which is a counter, and then taking its RTL, and then planning to take it through synthesis, then placement, then CTS and routing, and during synthesis we will do floor plan as well. So today I'm going to talk about compile, the basics of synthesis, what kind of optimizations we do. But before that, let's step back and take a look at our overall flow, where we are, what we need to cover. So, what we need to cover next. So, and I am going into details of it. Instead of just giving you a high level explanation and moving on, I am giving you actual flow. Yes, actual flow. I'm using Fusion compiler as an example in this one, because the training I gave in KSA last month was they had synopsis tool, so I used those synopsis tool as a way to take this RTL block through routing. But whatever, if you have other tools like cadence tools, there will be similar equivalent commands. Hopefully I can maybe do a take this block through Janus Innovus as well, so that I have flows, my own flows for both tools, and hopefully I can do an open source. I keep saying that, but let's see how much time I need to finish this series, and then after that I'll figure out what next. Okay, so what we have done so far is library setup. We look in detail. We created a design library. Okay, then we read the RTL. Then we applied timing constraint. Then we read TLU plus. Then we initialized a floor plan. We gave it commands. Then we looked into power grid in detail. Okay, there were some commands within the initialized floor plan where I gave constraints like, okay, the pins, the ports of my design, place them on this side or that side, and what kind of metal to use and all that. You will not see that right away unless you do an initial compile, an initial synthesis. Whenever I say a compile, I mean actual gate level synthesis. Gate level synthesis, as we will look into hopefully today, if not in the next video, it has, at least the tool that I'm using, it gives you synthesis operation in different stages, and a simpler conversion to all the full highly optimized one. Okay, but in order to see the effect of some of these constraints, the pin constraints and area constraints we give, for example, we can say, okay, give us a floor plan with a 75% utilization, 70% utilization, or maybe you already have coordinates, you know the width and height. I am in most of hierarchical physical design. If you are on a block, you will get those constraints from the top level floor plan person or design planning person. But in this example, I will be initializing that area. So just think that block that I'm taking counter, that is your top level, and your top level is kind of flat. It's not a hierarchical approach, it's more a flat approach that we're adopting. Okay, so we definitely need an initial compiler to do that. There were steps in power grid that where I explained that initially a ring structure and mesh you can actually do without that, but the code that I was using for standard rail connection, you need to have a final synthesis legalized placement. So, and I also explained power grid is not you're gonna implement every time you do it. Floor plan is also not something you're gonna do every time. So once you've done the few times, you will be in a design planning phase. Once you've done those, you will write out a tickle file or def file, and the next time you can read that in. So these are, now maybe I should do is this one is, these are a bit more like what I should call design planning. So I'm doing a gate level synthesis, but before that I'm doing some initial design planning as well. Okay, design planning, just want to make sure you know this term DP. So the way I'm going to do is some of these things that I have here and here, they need some sort of initial synthesis. So that's why I am doing this initial synthesis. So this is kind of, you can, it's not a loop, but yeah, it can be a loop. You do this, you figure out, you undo this, you go back and you do this again. Okay, so you need to circle around that. You need to iterate over this to come up with your final floor plan and your power grid. All right, and once you have that, then you move on. So I put this initial compile here, and also my methodology on this scan insertion, the DFT that I'm going to touch, is also that I expect that you already have an initial gate level netlist. So that is also important in the flow that I am doing right now, that you have a compile done before insert DFT. You can use also approach of DFT where it's not required. In that case, you can run it before. Okay, but this flow, which I call my flow, is really based on the steps I mentioned to you. So you will see that I actually do synthesis over where I do a full compile here. Further compile, what I call it here. These are high, oops. Yeah, okay, I like that. So we will do it again after insert DFT, but first we will do this. But the concept of compiles, what is compile, what are different stages, what kind of optimization it does, and all that, I'm gonna cover together. But in the flow, I'm gonna use this one. I'll show you exact commands that I'm gonna use here, and then I'm gonna use those. So let's finish this video here. My next video will be on this whole idea of compiles. Okay, and yeah, all right, that's it. See you next time. Take care.